Hello everyone, this is Math 111Z, and this is section 3.4, covering zeros of polynomials and solutions of equations. So let's just kind of take a look at our first example here. It says show that x is a zero, which means that it crosses the x-axis. So anytime a polynomial crosses the x-axis at that point, we call that a zero or a root. So it says show that x is a zero at of this polynomial, and then to use that fact to factor this polynomial completely. So to find all of the other zeros and to factor the polynomial. So there's a number of ways that we can do this. The first way to show that something is a zero, and probably the easiest way, is to simply just plug it into the equation. And if you plug that number in and y equals 0, then you have a 0. So if I go 3 times 4 raised to the third power minus 4 times 4 squared minus 48 times 4 plus 64, then from here, I need to show that that equals 0. So this is 3 times 4 times 4 is 16 times 4 is 64, minus 64, minus 192, plus 64 equals 0. This is 192 minus 64 minus 192 plus 64 equals 0. And that's very convenient, so we have 0 equals 0. Right? So what that tells us then is that 4 is a factor. And if it's a factor, then like P of 4 equals 0. Also, x minus 4 is one of its factors, and 4 comma 0 is an intercept, one of the x-intercepts. So if I want to use this fact to factor this completely, I have some different options of the ways that I can do this. And this is going to be some quick review of your Algebra 2 course that you had. But let's take a quick look at this. Let's take a quick look at this in problem number 1. All right, so relating zeros, factors, and x-intercepts. So p of x equals 0. Fill in table 1. All right, so if this is equal to negative, if, for example, g of x has a 0 at negative 1, then you have a factor of x minus negative 1, which is x plus 1. And your intercept is negative 1 comma 0. If you have a factor of x minus 3, then your 0 is at 3. Again, let's just sidestep. This is x minus a negative 1, okay, which makes x plus 1. So this is x minus 3, so you have a 0 at 3, and your intercept is at 3 comma 0. If you have an intercept at 5, 0, then this is 5, and your intercept is x minus 5. All right. All right, let's move on here to the rational root theorem. Okay. Here's our function right here. Now, we know that x of 4, x minus 4, is a factor. There are 2 ways that I can figure out how to take that out, right? How to divide x minus 4 out of there. One is known as long division. And here I put the x minus 4 outside, and then I put my polynomial inside, making sure that I have a term for every degree, which I do here. So I have a 3rd degree, a 2nd degree, a 1st degree, and a 0 degree term. If I didn't, I would just put a placeholder of 0x squared there just to help me out. And I say, how many times does this go into this? It goes in 3x squared. That's what I need to multiply this by to have it look like this. So then I multiply that out, which would be 3x cubed minus 12x squared. And then I change the signs and add. Also known as subtracting, but I always like to say change the signs and add because you're much less likely to make a sign error then. So I change all the signs and add, and I get 8x squared here. Bring the rest of my trailing terms down, and now I repeat that process. What do I have to multiply x by to get 8x squared? I need an 8x. So I'm going to go 8x squared minus 32x. I'm going to change the signs and add. And now that's going to go to 0. And I'm going to add 48, negative 48 plus 32 is negative 16. And, I'm sorry, that should be 64. All right, so, and now I'm going to say, what do I need to multiply this by to get this by to get this? That's a negative 16. And multiply those through, it's a negative 16x plus 64. And I change the signs and add. And that goes to 0. And this also goes to 0, so you should have a remainder of 0. If you don't have a remainder of 0, you know you did something wrong because you know this goes in evenly because you know it's a factor. So if something goes in evenly, then it's a factor. You should have a remainder of 0. So now I have this factored out. My next step is to factor this quadratic. And we have lots of methods that we can factor a quadratic. We know that has to be an x and that has an x. When I multiply those two things together, things that make 16, and multiply them by 3 and 1, they need to subtract to positive 8. So if I do 16 and 1, obviously that's not going to work because I'd have 13, or I'd have 43, or 47. If I do 4 and 4, I would have 12 minus 4, which is 8, so that will work. Now the one that makes a 12 needs to be positive, because this 3 with that 4 makes the 12x, and then we're going to take away that. So these, now we have it factored completely. If I wanted to find the zeros from here, all the zeros of this polynomial, I could set this equal to 0, and then I would say, okay, this has a 0 at 4. This factor crosses over at 4/3. And again, I'm saying x minus 4 equals 0. I'm doing this in my head, so I'll write it out for you. 3x minus 4 equals 0. Add the 4 to both sides. 3x equals 4, divide by 3. X equals 4/3. And x plus 4 equals 0, which is x equals negative 4. So I get those 3 factors. Okay, I want to show you an alternative way of doing this as well. That's oops. There we go. All right. Instead of using long division, because we are factoring out a linear factor, we can use something that is known as synthetic division. And the way that you do that is you take, if you have x minus 4, you take the opposite of this. So you put the 4 here, which is your 0. You put your 0 in the box, right? And then you list out your coefficients from each term. And you have to put a 0 placeholder if there's not a term. So make sure you in this case, we don't need a 0 placeholder because all 4 terms are there. But again, if there was no quadratic term, I'd put a 0 there, okay? So now, the way synthetic division works is that this number drops down. Then you take 4 times your 3, and you put it here. That would be 12. And then you add them together, giving me 8. Then you take 4 times 8, which gives you 32. You see, these are the same numbers that we saw in the other one as well. This gives you negative 16. Then we take 4 times negative 16. It gives you negative 64. If you did it right, your remainder term, this last column, is going to be 0. Right? Now, this is a cubic. We took 1 degree away, so now this becomes 1 degree less. So x squared plus 8x minus 16. And that is called synthetic division, and there will be some practice problems like that, I believe, on your homework this week. Right? So, that is how you could do that first example. All right, so we're going to take another look at the rational root theorem. The rational root or 0 theorem. All right. It says if you have an nth degree polynomial, so if you have a to the n, x to the n, plus a to the n minus 1, x to the n minus 1, plus, so any polynomial has n degrees. Then 2 things happen. 1, if you have an nth degree, then it can cross the x-axis or have it can have at most no more than n real zeros. So it can't cross that line more than n times. You can't touch that line more than n times. You can touch it less than n times, but not more than n times, right? And then second, if all the factors of a to the n are a set, you list all the factors, and we call that any factor out of that Q. And we take all the factors of a to 0 and put it in a set, and we call that set P. Then if it is a rational 0, if a rational 0 exists, might not exist, a rational 0 might not exist, but if a rational 0 does exist, then it has to be of the form P over Q. Okay? So let's look at an example. Let's say I am taking, let's just take this parabola right here. Parabola, quadratic, excuse me. It is a parabola, but, all right, so this factor is like this. All right? Which means that we have zeros at negative 3/5 and 7/2, right? Notice that 3 and 7 are factors of 21, and 5 and 2 are factors of 10. So if I were to apply this theorem, let's say I was looking at factoring this cubic right here. Then I would look at all the factors of 2, which are 1 and 2, and all the factors of 3, which are 1 and 3. And if there are any rational zeros in here, I would, they would have to be either 2 over 1, plus or minus, or 2 over 3, or 1 over 1, or 1 over 3. Those are the 4 possible, well, actually 8 possible zeros that I could have. Now I could plug each of those into a table. I can plug each of these into this formula. So what happens if I put negative 2 in? If I put negative 2 in, I get negative 44. That's way too big. That's not 0. What happens if I put negative 1 in? I get negative 6. What about negative 2/3? I get negative 0.88, repeating. What if I put in negative 1/3? I get 1.556. Now, notice in between these 2 points, there is an irrational 0 because I went from negative to positive, but not a rational 0. So when I find this rational 0, that tells me that I'm going to have a quadratic left over, and when I take that quadratic, it's going to have irrational square roots in the answer. Right? Between these, the square roots, one of the square roots is going to be in between these 2 numbers. And then I take 1/3. And that's 1.1111. And then I do 2/3. Oh, look at that. I'm at negative 0.444. The other one, square root is going to be between these 2. These are both irrational zeros between these. I know that because I go from positive to negative here. And then I try 1, and I get negative 2. And I try 2, and I get 0. Right? So this is, I factor out this x minus 2. And I'm left with, I'll do this using synthetic division again so you can see what that looks like. I put the 2 and the 0 there. 3, negative 6, negative 1, 2. Drop it down, I get a 3. 3 and 3 is 6, that's a 0. 0 is 0, negative 1, negative 2, and that's 0. It has to end in 0, or I've done something wrong with that just because I know this is a root. That gives me 3x squared minus 0x, or plus 0x, either one, minus 1, which is 3x squared minus 1. So now if I want to look at all the roots, it is when is this 0, and when is this equal to 0? X minus 2 equals 0, of course, at x equals 2. 3x squared minus 1 equals 0 when 3x squared equals 1, when x squared equals 1/3, when x equals plus or minus the square root of 1/3, which is plus or minus 1 over the square root of 3, which rationalizes to plus or minus root 3 over 3. So these are those 2 square root zeros that we have there. Okay, so this final slide is about Descartes' rule of sign, and it's helpful, but it's not super, it's not crucial, it's not going to save you a ton of time, but it is kind of helpful, so I'll just kind of go over it real quickly. Suppose I have a polynomial that looks like this. Notice that look at how this changes sign. This is negative, then it goes positive, then it goes negative, then it goes positive. So this changes signs 1, 2, 3 times. So because it changes signs 3 times, then it could have 3 or 1, so or 2 less, or an even number less, because irrational roots always have to come in pairs, right? Because they have square roots. So if you don't have square roots as coefficients, obviously you're going to have, you had to multiply 2 square roots together to get no square roots in your coefficients. So irrational roots always come in pairs. So you're going to have 3 or 1 positive roots. Now, if I put a negative p in here, a negative x, excuse me, negative x keeps this negative x to the fourth power, would just be negative 3x to the fourth still. Plus, and this would still be, because if I put a negative x here, that would be plus 4x squared still, because x squared is just, a negative is a positive, so it doesn't change the sign. But if I put negative x in here, this would be negative 3 times negative x plus 2. So this actually becomes negative 3x to the fourth plus 4x squared plus 3x plus 2. Now notice that there's just one sign change. So if there's a rational root, there's only one negative root. That's there. So let's do one more example. Say I have 4x to the fourth minus 3x cubed plus 2x minus 1. So this is p of x. All right. Let's count our sign change. Positive changes to negative. That's one change. Changes to positive. That's another change. Changes to negative. So there's 3 or 1 positive, possible, positive roots. I'll put a negative inside. Now this, it becomes 4x to the fourth, because that's even, and this becomes plus 3x cubed minus 2x minus 1. So there's only one sign change here. It goes positive, changes to negative, stays negative. So there's just one possible negative root. So if you find one root that's negative on your list, you don't need to try any others. And that's kind of how that works. All right, I hope this is helpful, and let me know if you have any questions. Thanks, bye.